Mr. Cubic here. This is the class notes for September 28th, 2021. So you guys are on a field trip, and I put the notes for you on too, so I'm going to try and keep this probably about 15 to 20 minutes. We skipped section 2.7, so just if you don't, you're not going to go straight to the next one. We moved on to 2.8, which is on reciprocals. And so this is really just setting this up for 2.9, where we learn how to divide, which is really just multiplying by the reciprocal. Homework tonight is page 81, 3 through 33 Mott. The homework will probably take you about 10 minutes, so the video will probably take you a little bit longer. And then as a reminder, we have a test on Friday. The scrimmage will be online, and the answers will be online as of probably Tuesday at the latest. All right, so this lesson is on reciprocals, okay? So I am going to add some stuff to when I start, but let's go ahead and say, what is a reciprocal if we're talking about a reciprocal? Okay? So I would say, given a real number x, okay? And I'm going to leave a blank here, right? So leave a good 2 inches in your notebook, okay? Its reciprocal is 1 over x. That's it. That's the definition, 1 over x. So the reciprocal of 5 is 1/5. Reciprocal of 2/3 is 3/2. Reciprocal of negative 2/3 is still negative 3 over 2. So it's not going to change the sign. It's just going to flip it, is what most people say. Just flip it. Okay? And so this is the definition. Okay, that's also the notation. So what you guys probably want to say is what is defined as the multiplicative inverse property, or a better name is the reciprocal property. Okay? So, again, I'm going to say any, and then I'm going to leave word for 10-letter word right here, number times its reciprocal is 1. So that would be the reciprocal property in words. If I asked you what is the reciprocal property in symbols, okay, right, how would I write that as an equation using symbols? Well, any number is x times its reciprocal. We just learned that the reciprocal is 1 over x is equal to 1. And so we have the opposites property. Any number plus its opposite is 0. That would be the additive inverse. The multiplicative inverse, any number times its reciprocal, is 1. And again, I'm going to leave a little space here, probably like ½ inch. All right, so that's the first part. Again, you can. One nice thing about the video is you get, at any point, you can rewind it and go back. So I'm going to move on. There's one other. The book has this in there, and I wouldn't do this. Actually, you don't have to see my ugly face. Okay, the book has this, and I would not do this. Opposite of a reciprocal. So sometimes you have a reciprocal 1 over negative a. So the original number is negative a, and the reciprocal is 1 over the original number, so 1 over negative a. So, right, I want you to know that that's equal to negative 1 over a. That's all that this property says. It's kind of a silly property, okay? It's kind of a silly property. But that is what it is, right? And I would add that it's equal to negative 1 over a. So a lot of times we'll be going over the answers to the homework, and I'll be like, all right, so, you know, you have x minus 5 over negative 2. Right? So this would correspond to this first one because negative 2 in the denominator is the reciprocal of 2. And then, right, on my answers, I'll make that negative x minus 5 over positive 2. And you have all these guys that are like, wait a minute, Mr. Cubic, that's not what's there. And I don't even think about this. They're all the same thing, right? So we just learned multiplying. If I have a positive times a negative or a positive divided by a negative, it's negative. If I have a positive over a positive and then make it negative, it's negative. And if I have a negative divided by a positive, it's a negative. So all three of these are negative. So the negative could be in the denominator, the negative could be in the numerator, or the negative could be out front, and they're all the same thing. It doesn't make any difference whatsoever. Now for me, that's just kind of like a no-brainer. But I've also seen probably about 50 or 60,000 math problems in my time. And I, maybe when I was your age, did not understand that. But I just want you to know, it doesn't matter where the negative is. It only matters that there's one negative. Right? So let's go ahead and write that in words. Right? It doesn't matter in a fraction where the negative is. Right? And by that I mean it can be in the numerator, in the denominator, or just in front. Neither in the denominator or the numerator. Right? So long as there is exactly one. Right? So if you put two negatives, then that makes it positive. If you put three negatives, then we're back to where we were. So that is the property. You're never gonna need to know by name, but I do want you to know that when I write the different things, and you're like, wait a minute, then they're all the exact same. Now the last thing is very important, and it's the reciprocal of 0. So I guess I would ask yourself to start, what is the reciprocal of 0? Now, this is incredibly important, and this is going to come up in about 50 different ways throughout the year, and guys always get confused. So I'm going to explain it to you a few ways, and hopefully you remember it. So let's just say I start with the number 0. Well, that means that the reciprocal of 0 is 1 over 0. Okay? And, right, I know that any number times its reciprocal is 1. So I have two dueling properties right now. I have one property that tells me that any number times 0 is 0, which means that 1 over 0 times 0 equals 0. And I have another property that tells me that any number times its reciprocal is 1. So is 1 over 0 times 0 1, or is 1 over 0 times 0 0? And this is a real problem. And I want you to understand it. It's not, right, this is something that like kind of is an inconsistency that mathematicians had a lot of trouble with for a long time. And the answer is, I can't resolve this. So the way we resolve it is saying 0 does not have a reciprocal. Okay? 0 does not have a reciprocal. So if I ask you, what's the reciprocal of 0? You tell me that's a trick question, Mr. Cubic. And you would be right. So another way to think about it is, PJ is in 5th grade now, but last year he was in 4th grade, and they started really using fractions a lot. And so he had 1/3. And I said, what is 1/3, PJ? And we said, well, we're going to take the pizza, and we're going to cut it into 3 equal pieces. And I am going to color in one of them. Okay? So, right, I take one piece, right, out of the whole. Right, so it's part of the whole. Right, so 1/3, right, is that. So what if I gave you, I don't know, 2/5, right? So then I take my pizza, okay, and I cut it into 5 pieces, and I color in 2 of them. So that's what 2/5 looks like. I'll edit out that sneeze. All right, so then you said, well, what about, I don't know, 3/4? All right, so hopefully you're saying this is pretty easy. All right, so I'm going to cut the pizza into 4 pieces. And I'm going to color in 3 of them. Right, so this is what a fraction means. So Mr. Williams, he's a big fan of doing it on the candy bars. I don't like the candy bars as much, mostly because the middle pieces don't have chocolate on each side, so you're not cutting it into equal pieces. So then you say, all right, well, what would 1/0 look like? Okay? So the question is, right, how can you cut a pizza into 0 pieces? Okay? And this is hard. I mean, but that's what it means, right? So that means that the whole pizza is 0 pieces. You're like, okay, well then I'm not going to cut it. Right? Well, that means that there would be 1 piece, the whole pizza. How can the pizza be 0 pieces? It can't. Right? And if you think about it, the definition of a fraction, okay, you just can't have a 0 as your denominator. All right? So the denominator can never be 0. Right? So then you say, well, what if I think of it as a division problem almost at the bottom? Right? So what if I had, 5 divided by 1? So I say, well, how many times does 1 fit into 5? And then I have 12 divided by 2. And I say, well, how many times does 2 fit into 12? And then you have 8 divided by 0. And the question is, how many times does 0 fit into 8? I don't know. A lot? A little? I mean, what does that mean? Right? So the way you think of it is, you cannot divide by 0. So and if you ever see the fraction 8/0, you would say that that is undefined, which is abbreviated UND. You could also, if you feel a bit saucy, write DNE, does not exist. Or if you want to be a little nerdy, you could write infinity, because you could say an infinite number fits in there. So the infinity symbol is an 8 on its side. So those are your 3 choices if you happen to see 0 in the denominator. And this is really important. So there's 3 ways of saying the exact same thing. And I want you to understand, I'm not, right? So one way to say it is 0 does not have a reciprocal. The second way to say it is the denominator can never be 0. And the last way to say it is you cannot divide by 0. This is an incredibly, incredibly, incredibly important concept. And I can almost promise you that every one of you is going to miss one this year, even though right now it seems pretty easy. It appears a lot of times, like it's just always kind of lurking out there, trying to trying to nab you. So if we go back to our beginning of our notes, it says, given a real number, its reciprocal is 1 over x. Well, that's true for every number except I hope you guys are all saying this at home. 0. Thank you very much. Okay. Here, what number times its reciprocal is 1? Well, any number except 0. So we could say any non-zero number times its reciprocal is 1. And when I write it in symbols, you would just tell me any number times its reciprocal is 1, except x can't be 0. So you say 0 with a line through it does not equal. So those are the important notes. That's the thing I really wanted you to do. Hopefully you guys didn't just blow me off and just do the homework, that you actually went through and watched this. So I'm going to do 6 quick problems for the homework, and hopefully this video will be 20 minutes like I promised. So here it is, 6 problems. And these are all, the homework is 3 through 33, so these are problems off the homework but not assigned. So here, I have 1 over x times 5x. So if I did this, I would just cancel and say 5. Okay? If you want to know exactly what's going on, so you have 1 over x times 5 times x. So I'm allowed to flip these by the commutative property. So I get 1 over x times 5, right? And then I know that any number times its reciprocal is 1, which means I get 1 times 5, which is 5. Pretty easy. I did it the long way and it still took a minute. So here again, right? Technically what I have is 6w times w, but by the associative property, I could change it to this. Any number times its reciprocal is 1. So my answer is 6. And again, I want you to know, I would never do it this way. This is how my work would look. Okay, that's all you need to do. But I just wanted to show you that the properties that we learned are still apply. So again, short way, zoink, zoink, 4 equals negative 4. So that's how it would look in my work, right? If you wanted to do it the long way, you would say negative 1/12 times 12 times 4. Any number times its reciprocal is 1, so I get negative 1 times 4, which is negative 4. All right, problem 4. Negative 150. I'm going through these fast. What I would suggest is after I read it, you pause it, do it on your own, and then see if you did it right. Negative 150 times 1/2 times negative 1/3. So again, I could do a lot of things here. Maybe one thing I could do is multiply the reciprocals. So I get negative 150 times negative 1 over 6. I don't know if that's easier for you if you don't know that how many times 6 fits into 25. I don't think it makes it any easier. You might want to do it in 2 steps. I have a negative times a negative, which means it's going to be a positive, right? If the signs agree, the answer is positive. So really all I need to do here is figure out what is 150 over 6. So I know that 6 goes into 15 twice, with 30 left over. 6 goes into 35 times. My answer is 25. There's one I think it might have been easier to do 150 over 2, which is negative 75, and then multiply that by 1/3, and you get 75 over 3, which is 25. Maybe it was easier not to combine those. But again, any way you can find the answer without using a calculator or Siri. All right, so this is the one. Right, so this is like real math. It's almost like when you see algebra. So the first thing is I have to use the distributive property of multiplication over addition. So even though that is subtraction, it still works. So I have negative 1 over 7 times negative 42m minus negative 1 over 7 times 91k. All right, so here 7 times 6 is 42, so I can cancel and make that a 6. I have a negative times a negative, which is a positive, and my answer is 6m. Now here, I have a negative times a negative, which is a positive, but I have to leave a plus in between, otherwise I'm going to think it's a multiplication problem. And then I say, how many times does 7 fit into 91? Well, I know it goes in more than 10 because that's 70, and the answer is 13. So my answer to this one is 61 plus 13k. Now, if you're confused on that, let me just go through it slow. It's just one of those things that for me this is easy, and hopefully you'll think it's easy, just maybe not tonight. So I have a multiplication problem, so I distributed this negative 1/7. Make sure when you distribute that you bring the negative to both. So I have negative 1/7 times negative 42 became positive. I have negative 1/7 times negative 91, and they became positive. So that's why that's a plus sign, and all the negatives disappeared. Next, I did 42 divided by 7 is 6. The m is just 6m. And I did 91 over 7, which is 13, and that's just 13k. So this one, again, I would suggest you pause it and try it before you do it. So I have negative 1/8 times quantity 48m minus 16 minus 1/4 times quantity 84m plus 8. All right, so hopefully you paused it. This is how you solve it. So I have two distributions going on. And again, I'm going to show a lot of work. I don't know if I would necessarily do all this. So there's our universal sign for distribution. I have negative 1/8 times 48m minus negative 1/8 times 16 minus 1/4 times 84m minus 1/4 times 8. So here the 8 cancels off the 48 and I get negative 6m. Here I have a negative times a negative, so it's a plus. 16 over 8 is 2. Here I have negative 1/4 times 84, which is negative 21m. And here I have negative 1/4 times positive 8, which is negative 2. So first I distributed, then I multiplied. Now I gather. Negative 2 plus 2. Those guys cancel. Negative 6m minus 21m. Holes plus holes is, wait for it, more holes, negative 27m. So one thing about this video, you guys, is if you are confused on something, you can always go back and rewind it. Good luck on your homework. If you didn't watch the video, I still think you could do fine. And don't forget the test on Friday. Peace.